Hi everyone, so today we're working in section 1.8, so 1.8, and you should have your note packet out. But before we start, I want to review a few terms to make sure you remember from earlier classes that you've taken what the term perimeter means. So perimeter is, kids always tell me it's all the sides added up. That's true, but it is the length around a figure, okay? So it's the length around a figure. So if I say I'm asking you to walk around the perimeter of the building, you're walking around the outside of the building. Oftentimes when we are talking about perimeter, you're going to hear in word problems, we're going to be talking about, I don't know, we're fencing in a yard. That would be the perimeter, right? The fence. This would be the fence around the yard, or I don't know, we're putting up a fence for a corral in a horse farm. Something like that. All right, circumference is actually the perimeter of a circle. And the reason it has a different name is because when we talk about perimeter, we say add up all the sides, right? We say add the sides. Well, circles don't have sides. So I like to think of it as the perimeter of the circle. So it's the outside of a circle. Oops, my circle came out badly there. Let me delete that. So there's my circle. And the perimeter would be the outside of it. So right there. I like to also think of the crust of a pizza. The crust of a pizza is like the circumference, and you can remember C with the crust. All right, so the area of a figure. The area of a figure is everything inside the figure. Everything, think of like carpeting your floor, everything on the floor. Or if I want to paint the wall, that would be area. So that's everything inside the figure. And the big thing to think about here is everything, when we're talking about all of these area perimeter, we're talking about 2D figures, not three-dimensional, because that takes us to a totally different place, okay? Not that we won't go there, but okay, so let's review our common formulas. The first thing that we need to know is a square. All right, so a square is it's a four-sided figure, with all equal sides and all equal angles. And I'm using symbols there for angles. All right, so a square looks something like this. All the sides are equal, so I can mark them congruent. And since all the sides are equal and all the angles are equal, the angles all work out to be 90 degrees. So I'm going to put the little box there. So that's my square. All right, so if I told you that the side of the square, we're going to call it S, and I asked you to find the perimeter. Well, then that means all four sides would be S, so I would label them. And if I add up all the sides, S plus S plus S plus S, I would get 4S. So that's the formula for the perimeter of a square. All right, area of a square. All right, well, area is when you multiply the sides together. So if I did S times S, I would actually get S squared, S to the 2 power. So notice the difference between adding S and multiplying S. When we add S, we combine like terms. When we multiply with S, we're dealing with those laws of exponents. All right, a rectangle. A rectangle is kind of like a square. However, it doesn't have all equal sides. It does have 4 right angles. So a rectangle looks like this. It does have those 4 right angles, but only opposite sides are equal. So the 2 opposite and then these 2 opposite, using 2 hash marks, are equal. All right, so the longer side we always call, in a rectangle, we call it the length, and the shorter side the width. So to find the area of a rectangle, we just do the length times the width. We multiply the 2 sides together. To find the perimeter, we add up all the sides. Okay, so if this is L, then this would be W because they are congruent, they're equal to each other. If I add up all the sides, I have L plus W plus W, which would give me 2L plus 2W. Okay, you guys are doing great. All right, triangle. We know it's a 3-sided figure. Looks something like that. So I'm going to actually draw a big one. We got to know the parts of a triangle, okay? So inside the triangle, there's this line that goes from a vertex straight down. I'm drawing it from that vertex, but you can draw it from any one of them. and it's perpendicular to the base. So this side that line goes into, we're going to call the base. We're going to give it the variable b. Well, that line in a triangle, we actually call it the height. Okay, and another name for it is altitude. And you've probably heard the term altitude when you are on a plane, right? Because you're high up. You're at a high altitude. All right, so we call that variable h. All right, so to find the area of a triangle, we do base times the height, and we divide it by 2. And we're going to talk about where we get some of these formulas tomorrow in class, but for now I just want you to get used to the formulas because we are going to need to know them. And they are also on your Quizlet. So, and I'm sorry for my voice. I'm not feeling so great today. All right, a circle. All right, so we've got to go for a circle. First of all, in a circle, we need to remember that we have a line that comes from the center of the circle to the side of this, or to the circle. That's called the radius. We also have a line that goes through the whole circle, also going through the center, but it's the whole length. So it's like 2 radiuses. We call that the diameter, and we use D for that. All right, to find the circumference of a circle, you actually have 2 options. You can either do 2 times pi times r, or pi d. Well, that should kind of make sense to you because r times 2 gives me d. This is an r right here, and this is an r right here. So 2 of them would be the length of d. All right, and then to find the area of the circle, we say pi r squared. And I know that some teachers over the years, they come up with these cute little mnemonics, and I used to say, cherry pies are dope, and apple pies are too. That was just one way for me to remember that it was pi r squared. So cherry pies are dope, and apple pies are too. All right, how do we use this? All right, so we want to look, we have a picture frame. We have a frame of a picture, and the picture is 5 by 7, and it has a 1-inch frame around it. So it asks me, what's the perimeter of the picture? All right, so I'm going to draw a picture. I have a rectangular picture. It's 5 by 7. I'm trying to find perimeter, so I might even highlight that word because it's different than area. I know that it's a rectangle, so I'm going to mark my sides congruent, labeling my diagram. If this side over here is 5, then I'm going to put a 5 over here. And if this side's 7 up here, then I'm going to put a 7 here. To find the perimeter, we just add up all the sides. 5 plus 5 plus 7 plus 7. So we get 10 plus 14, which gives me 24. All right, so what is the perimeter of the outside edge of the frame? All right, well, now we've got to put the frame around it. So here I've got this picture that's 5 by 7. I've got this frame going around it. And this is 1, and this is 1, and this is 1, and this is 1, because it's a 1-inch frame going all the way around. All right, so we actually have to calculate the new side of the new figure. So if I tell you that this is 7 right here, this segment, the part of the frame is 7, and this is 1 right here, and this is 1 right here, so 1 and 1. If we add them all up, 7 plus 1 plus 1, we get 9. So now we've just increased the size because we added the frame around it, right? What about right here? All right, so if it's 5 and then 1 and 1 on both sides, that's going to give me 7. All right, we go through that process again. We put the 7 across because it's rectangular, and we add up all the sides. So 9 plus 9 plus 7 plus 7 gives me 18 plus 14, which is, let's see, 32. And that's the perimeter of the frame. All right, let's look at circles. A couple different ways I can ask for circles. I can ask you to give me the circumference in terms of pi or to the nearest tenth. If I ask in terms of pi, that means I want pi in the answer. If I ask to the nearest tenth, I want you to use your calc. Okay, so you are going to have to know the difference. All right, so it's asking me for circumference. So this might be where I take my highlighter and highlight the word circumference. And I want the circumference, so I'm going to write the circumference formula for a circle. Circumference formula is 2 pi r. All right, it gives me the radius, so it says that r is equal to 23. So I'm going to take that 23, and I'm going to plug it in for the r in the equation. Another word for plugging it in is called substituting it in. So I'm going to do 2 pi 23. Now, we know that all of these values are being multiplied. So the 2 and the 23 I can actually multiply and get 46. And the pi remains, so my circumference in terms of pi would be 46 pi. All right, so that's how you leave it in terms of pi. Now, I want you to round to the nearest tenth. All right, so, but this one gives me diameter. So I'm not going to use the 2 pi r formula. I'm going to use the formula C equals pi d. Okay? All right, so I'm going to plug in the 24. I'm going to actually rewrite it for myself as 24 pi. We always want to put pi at the end. Treat it like a variable when we're doing it. Now we're going to go to the calc, and you're going to find the pi feature on the calculator. So you do have to press the second feature usually on the bigger calculators to do that. So I'm going to ask you to go ahead and estimate that for me because I actually don't have my calculator handy. And I'll check your answer tomorrow. All right, one more. So it says graph the quadrilateral. Graph JKLM with vertices. J is 3, negative 3, so I'm going to do that. Negative 3, which is down here. When I do that, I am going to put the points. So negative 3, negative 3. And then K is 1, negative 3, so right here. So 1, negative 3. And L is 1, 4. So I'm going to go all the way up to 4 up here. And I'm going to label it 1, 4. And then negative 3, 1. So negative 3, 1 is right here. Remember, all coordinates are in the coordinate point xy, so they're in the form xy. All right, so now I'm going to connect them. So I have this nice figure. It's a 4-sided figure that looks something like that. All right, so in looking at this, guys, we can see that we have some horizontal and vertical segments, and to get their lengths, because we're trying to find the perimeter, so we need all the side lengths, those are actually the easy ones. We can just count across. So from this point right here, all the way to this point right here, if I count across, I've got 1, 2, 3, 4 units. So I'm going to put a 4. Its length is 4. All right, the vertical segments, I can do the exact same thing because they're going straight down. So I'm going to calculate from here to here by counting. 1, 2, 3, 4. Ooh, this side is also 4. I'm going to label it. All right, now I'm going to go to, how about black? Now this vertical segment, I'm going to count. I'm going 1, 2, 3, 4, 5, 6, and 7. So horizontal and vertical segments are really, really easy. It's when that we get to the ones that are diagonal segments like this one right here that we have to be careful. But we do know how to find the distance of a segment in the coordinate plane. We use the distance formula. And since this point right here was 3, 1, and this point right here is 1, 4, I'm going to use the distance formula. All right, so to remember the distance formula, D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Awesome. Now we plug in our points. So D equals, I'm going to do 1 minus negative 3, which is 1 plus 3 squared plus, I did 1 minus 3, so I'm going to do 4 minus 1 squared. So I get D equals 1 plus 3 is 4. 4 squared is 16 plus 4 minus 1 is 3. 3 squared is 9. 16 plus 9, I do that first, which is 25. Look at that. Coach Fred did a nice thing for you. The square root of 25 is 5. All right, so I'm going to put a 5 right there. And now what? I'm trying to find the perimeter. That means add up all the sides. So we're going to do 4 plus 4 plus 7 plus 5. So we get 8 plus 7 is 15. So 15 plus 5 gives me 20. So the perimeter of this figure is 20 units. Okay? All right, I'm going to stop there, and we're going to go over a little bit more tomorrow and then practice it all in class. All right, guys, thanks for dealing with my sniffly voice, and I'll see you tomorrow. Bye.